So direction. Direction answers this question. Do the variables tend to move in the same direction or the opposite direction of each other? A positive direction means that the variables move in the same direction together. A negative direction means that the variables move in the opposite direction from each other.
With an n of 4. Here we have data with a positive direction. So you can see as the stress level increases, so if we go down, this tends to increase from 10 to 23 to 35 to 42. The depression levels also tend to decrease. So they're going together. So it's going from 3 to 6 to 10. So as stress increases, depression also tends to increase. So we have a positive direction. So we could have, for example, R of 0.98. So this is very strong. It's positive and it's very strong because it's close to 1. So that's just an example of what the Pearson correlation coefficient will be. And the R represents the sample Pearson correlation coefficient. So that's the symbol we're going to use for the Pearson correlation coefficient. Here we have a negative direction. So as stress tends to increase, our happiness tends to decrease. They go from 10 to 23 to 35 to 42 for stress, but happiness tends to go down from 14 to 10 to 10 to 8. And so as stress increases, happiness tends to decrease. So we have a negative direction. If we calculate the Pearson correlation coefficient on this data, which you will learn to do on the next video, we'll get an R of negative 0.93. So this is still a strong correlation. It's a little bit weaker than the last one because the other one was 0.98 and this is 0.93. And it's in the opposite direction. We have a negative direction. So remember, when we're looking at the Pearson correlation coefficient, the strength, it doesn't depend on the positive or the negative. It depends on the number part. This is a pretty strong correlation. It's a little bit weaker than the 0.98, but it's still pretty strong. And this is a negative direction.
First thing that the number tells you, the correlation coefficient, is the direction. So the sum of the squares will be positive, and that's all the time. So at the bottom, it will always be a positive number. Okay? And then the sum of the products determines the direction of the correlation. So if most of the products are positive, then the sum of the products will be positive. If most of the products are negative, then the sum of the products will be negative. And so if the sum of the products is positive, then the correlation coefficient will be positive, because you have a positive divided by a positive. Remember, the bottom will always be positive. But if the sum of the products are negative, then the correlation coefficient will be negative, because you have a negative divided by a positive. So this is a positive correlation, and the scatter plot displays that correlation. And the simple reason of why I know that this is a positive one is because as stress increases, so does depression. So they're moving in the same direction. And I'm going to go in a little bit more detail why it's called positive direction. I mean, why use that term? Okay? And to do that, first I'm going to have to get the means here. So the mean of stress is 27.5. The mean for depression is 8.25. Then I'm going to get the deviations, at least get the sign of the deviation, so if it's negative or positive. And I'm going to put this in the chart here. And then I'm going to take the product of those deviations. I'm going to multiply them together. And first off, though, I'm going to put the averages on the scatter plot. So here's the average for stress, and we'll put a line there. And here's the average for depression, and I'm going to put a line there. Okay, now we have 4 quadrants to the scatter plot. So the 2 lines split the scatter plot into 4 quadrants. Okay, the deviation for stress in this bottom left quadrant will be negative. And that is because the dots are below the stress average line. But I'll go through the example. So we do 10 minus 27.5 for the first dot, and that gives us a deviation of negative 17.5 for stress. So it's negative 1. It's a negative deviation for stress. Let's do the other dot. Let's get its deviation for stress. So the next dot has a stress level of 23. We'll subtract 27.5, and we get negative 17.5. So that dot also has a negative stress deviation. We're going to put it there. Now we're going to talk about that same quadrant, but now we're going to talk about the deviations for depression. And the deviations for depression in that quadrant for those two dots are also going to be negative, and that's because it is below the depression average line. So, for example, we have 3 minus its mean of 8.25 for depression, and you'll get a negative 5.25. So 3 is below the 8.25 line. So we get a negative depression deviation for that dot. And then for the second dot, we have a 6, and we subtract the 8.25, and you get negative 2.25. And so that dot is also below the depression average line, so we get a negative deviation for depression. Okay? Now what I'm going to do is get the products for those two dots. And they're both negative for both of them, so if you multiply them to get the products, a negative times a negative is a positive. So the products for those two dots will always be, the products for those two dots is positive, and anytime it's in this bottom left quadrant, it's going to be a positive product because you're doing a negative deviation times a negative deviation because the dots are below both average lines. Now I'm going to do the next two dots and find those deviations. So this next dot has a positive stress deviation, and the reason I know that is because it's 35 minus its mean of 27.5, so 35 is above its mean, and we get a 7.5, so we get a positive stress deviation for that dot. Let's do the next one. The next dot has a stress level of 42, and that's above the 27.5, so we get a 14.5. So that's also a positive deviation for stress. Okay. Now we're going to do the deviations for depression in that same quadrant for those last two dots. So they're always going to be positive again because we're above the depression average line. So we have 10 minus 8.25, so 10 is above 8.25, so we get a positive deviation. And then for the last person, we have a depression score of 14, and we subtract off its mean of 8.25, and we get a positive deviation of 5.75. So that goes there. And then remember, we're going to multiply to get the products, so we're going to multiply the deviations. And a positive times a positive is a positive. So that's why this is called a positive direction, because the products are positive for those two quadrants. And then what you do is you add up the products, and if you add up a bunch of positives, you're going to get a positive sum of products. And remember, the sum of products determines the direction. So if you have a positive sum of products, you're going to have a positive Pearson correlation coefficient. If you have a negative sum of products, you're going to get a negative Pearson correlation coefficient. Now I'm going to talk about a negative correlation. So for a negative correlation, it means that as the one variable increases, the other one tends to decrease. So for the scatter plot, we have stress increasing, and then happiness will decrease as stress increases. So they're going in opposite direction. So just looking at this, you can see that it's a negative correlation. But I'm going to go a little bit more in detail on why it's called a negative direction and not just called something else. And it's going to be similar to the answer we found for the positive correlation, but now about the negative. And I'm going to go a little bit faster through this example. So we're going to have the averages here. So an average of 27.7 for the stress and an average of 10.5 for the happiness. So we put lines at both of them. And for this first dot here at the top left, we have a dot that is below the average stress line. So we're going to get a negative deviation, and it's above the happiness average line. So we're going to get a positive happiness deviation. We multiply those deviations to get the product, and we get a negative product. A negative times a positive is a negative. Then we're going to go to the next dot here, and it is below the stress average line. This gets a negative stress deviation, and it's also below the happiness average line. So we get a negative deviation. A negative times a negative is a positive. And you might ask, well, why are we getting a positive deviation if this is a negative correlation? Well, the answer is that for negative correlation, they're not always they might not always be negative for the products, but when you add them all up, overall it should be a negative sum of products. So just having a couple here and there that are positive isn't going to make the whole correlation not be negative. It's just going to make the strength go down a little bit. And the same thing goes for a positive correlation. Most of the products should be positive, but some of them may be negative or zero. Just overall, when you add them up, they should be positive. Okay? Now we're going to go to the third dot here, and we have a positive stress deviation. It's above that line, and it's below the happiness line. So we get a negative happiness deviation. A positive times a negative is a negative. And then the last dot here, we also get a negative happiness deviation, and we get a positive stress deviation. So positive times a negative is a negative. So for that last quadrant here, it's going to be negative. So if you have mostly negative products and then you add all the products up and you still get a negative sum of products, the correlation will be negative. Okay, on this side we have a scatter plot of no correlation or zero correlation. The dots are just random. And if you put lines here like we did before, so average stress level of 3 and an average number of freckles of 10, we put lines there. We can see we have dots in each of the quadrants. So that top quadrant is always going to be negative to the left, and the bottom right quadrant is going to be also negative for this product. And then this top right quadrant is always going to have positive products, and the bottom left is always going to have positive products as well. And if you add these all up, they kind of cancel each other out and equal 0. So that's why there's no correlation here, and it's 0. So here's kind of a summary of the direction. So this is a positive correlation. As stress increases, depression also increases. So this is positive. With scatter plot, as stress increases, happiness tends to decrease. So this is a negative correlation. For the scatter plot, there's no correlation because the dots are random. Here's more examples of direction. So the first one is a positive correlation. So we go from the bottom left to the top right, that's positive. We go from the top left to the bottom right, that's negative. And if the dots are just random, that is no correlation.